Welcome to Brain Vision.
We're told a 350 kilogram roller coaster starts from rest at point A and slides down the frictionless loop, the loop shown in the figure. I'm not going to try to reproduce the figure, but I assume that you have it. And then how fast is the roller coaster moving at point B, which is at the top of the loop? And how hard does it press against the track at point B? So we have, this is basically conservation of energy. So the energy when the roller coaster is at A has to be equal to what it is at B, since we're assuming there's no friction, and I guess we're also assuming there's no wind loss or air resistance either. And at point A, the roller coaster isn't moving, but it has some potential energy, gravitational potential energy. And I measured y from the base of the roller coaster. And then at point B, the roller coaster has some velocity v sub b, and it also has some gravitational potential because it's now yb meters or units from the ground. So if we simply say that the energy at A is this sum and the energy at B is this sum, we get that 1/2 mvb squared equals mg times ya minus yb. M's cancel out, and we simply get that that v sub b is the square root of 2g times the change in height, and if we plug in our numbers, we get about 16 meters per second. Now, as far as what the normal force is on the roller coaster, or from the roller coaster on the track, we can just look at the normal force from the track on the roller coaster, and it's going to be equal and opposite from the roller coaster on the track. So here's our free body diagram of our roller coaster at the top of the loop, and the track is hopefully pushing down on it and not trying to pull it back up, because unless there were some other wheels on the other side of the track, then it would fall. Then we have the mass of the roller coaster pulling it down, and we have the acceleration, the centripetal acceleration, wanting to push it out. And so we just use Newton's laws to say N plus mg must equal mv squared b over r. And if we plug in all of our numbers, we're looking for N, so that's m over r vb squared minus mg, and we can plug everything in, and we get that the force is 11,433 newtons. So again, it's nice and positive, so that we're not worried about this roller coaster falling off of the track at this point, because it's going fast enough to keep it pressed against the track.